Hello everybody, I will start my today's another coding practice. So in this video, I will solve this question, robot room cleaner. So, okay. So you're controlling a robot that is located somewhere in a room. The room is modeled as an m by n binary grid where 0 represents a wall and 1 represents an empty spot. 0 is wall and 1 represents empty slot. Okay, so 1 is where robot can move into. The robot starts at an unknown location in the room that is guaranteed to be an empty. And you do not have access to the grid, but you can move the robot using the given API robot. You don't have access to grid, but yeah. Okay. You're tasked to use the robot to clean the entire room. Clean every empty cell in the room. The robot with the 4 given APIs can move forward, turn left, turn right. Each turn is 90 degrees. When the robot, so move forward, turn left or turn right. Okay. When the robot tries to move into a wall cell, its bumper sensor detects the obstacle and it stays on the current cell. So it can't walk into bump the wall, but it just stops. Design an algorithm to clean the entire room using the following APIs. I see. Note that initial direction of the robot will be facing up. You can assume all 4 directions edges of the grid are all surrounded by. Okay, so let's see. Okay, so basically I will mutate the given grid and up. No, okay, I just called the API and I don't have to return anything or don't have to mutate the given array. So I mean, the API will move the robot by himself and confirm if the robot cleans off the room. And it is done, it's okay. But if it is not, I mean, the robot doesn't reach every empty cell, it means that my method is not correct. Okay. I see. It's so interesting. So main thing here is that I don't know how the grid cells are. So if I know them, if I know how it is, I just have to do the. No, wait a minute. Sorry, it doesn't matter. Yeah. Oh, sorry. So there is a statement here. Custom testing. Blindfolded. Okay. So I'm not pretty sure where the robot is in the cell. So yeah, as it says, blindfolded, I will think that I'm completely blind and I am a robot. And I will try to do turn left or turn right or just move forward by 1 step. And somehow I have to make sure that I cleaned all those cells. And but also I will be given the what it's given as a robot. Robot is API. Okay, and also I don't know how big is room is. Oh, so interesting. So let me think. Okay. I will assume that X is wall and circle is empty. So it is also possible something like this. Oh wait, and is it guaranteed that I can clean all the rooms? Arrows, empty cell can be, yeah. It's possible. Assume that I'm robot is here. In that case, the robot has to go, say, go down, go right, go up, go left. The robot have to move in a quite, tricky way. So I mean, it doesn't work if I just move the robot forward and then left as much as possible, right as much as possible. It may not work. I see. So assuming I'm a robot, what should I do? But I think it's still possible that I use a kind of traversal in this grid. However, I have to make sure that when I come back to the same place, I don't come back to visit the same space again and again. Because if I do that, say a robot can move to, in this case, move left, come back, and then go back to left again and do it forever. So I think I can keep track of the relative position from the current node. I mean current cell. I mean the start cell. So assuming that this is 0, 0, and if I go up, it will be -1, 0. Row is -1, column is 0. And then I will keep it as the visiting node. And I will come back to the 0, 0, and I will look for another cell. Oh wait, but problem here is move. Sorry. No, move method returns boolean, which represent if robot has moved or not. I can know if the robot there is a wall or there is a space. I see. Okay, so I think in this way I can use kind of DFS similar. So I will keep track of the stack, just like the typical DFS, and also visited cells, which is a set of tuples. Yeah. And also I will keep track of the yeah, I think these are two things I have to keep in mind. Yeah, so let me tell you again more detail about this DFS algorithm. So, I mean, when I so when I'm at here, I will move up. Okay, so be more specific. Directions should be yeah. The robot always visit and try to move Firstly up, and yeah, it moves up and visit this node, this cell. Then come back, and then go to right, then come back and go down. Yes. And then it tries to go up, but it already visited, so it never comes back. Yeah. Yes, so my idea is this visited set is actually cells which are already pushed into the stack. But the problem is, say, when I move down, no, move up, I don't want to come back. I need to come back here, robot, because I cannot move any other cell anymore. And to come back, I have to make sure which direction it should move. So for this tag, it should be row column position and also reversed. Let me say back direction. Yeah. So this row and column represents the current row and column, and row back and column back represent the direction to go back. So with this, if the robot goes up and visits this cell, it can come back, because I will take a look at up, left, right, left, and I find that all of them are already visited, so I just have to come back. Yeah. Then after coming back, I will take a look at left. Oh wait, the problem here is in DFS. Sorry, maybe I misunderstood something. In BFS, for example, if when I first visit 1, 3, 4, then 5, and then it comes back to this 9, it jumps to 9. But what I need to do is I have to backtrack. Yeah. So how can I backtrack? Maybe I can use the recursion with backtracking. So if I use that, I first revisit in this tree structure 1, 3, 4, and then come back to 3, then visit next 5. Yeah. But I think instead of doing the backtracking, I just have to keep in mind where I've come from and also the visited scene set. Yeah, I think so. So let me quickly change my idea. So instead of these, I will keep track of the back directions. So this is the directions, list of directions, and each direction is like 1, 0 tuple or tuple -1, 0, which signifies one step. So from the current robot position, if I go back to the back direction, I can always come back to the first position. Then also I will keep track of the visited cells. So this is useful because I don't have to visit any visited cells anymore. So say if I visit from here, I go down here, and then if I go left here, then if I go up here, then no, it's not good example. Sorry. Let me say this road goes to this direction and goes down, and because all of this, it goes this, then go visit this. Yeah, and assuming that this is already visited, yeah, in that case, the robot shouldn't go this direction. I will include the logic that robot never goes back to the direction as long as if there is another way. But even that being said, I have to make sure that the robot doesn't visit the same cell again. Okay. So that being said, I will move the robot as much as to the direction it has never visited and it didn't come from. And then I will do the kind of traversal. Then if I find that there is no way to go aside from the going back, I will just go back. And then from that, return position, I will look if there is another direction I can visit. Then if there is, I will move as much as possible. Then I will come back. Yeah. So let me quickly write it in this way. So road starts here, this way, this way, this way, this way, and assuming that there is, it's structured like this. Please assume that, sorry, this is just imagination. So please don't assume that there is robot can be this direction. Yeah. Assuming that, what happens is, okay, first three, the robot goes to straight forward. Yeah, if the robot goes straight, and it goes back one step and go to this one, and because there isn't any more no cell, goes back to here, and because this one is already visited, I will go back to this. Then this node is already visited, there is no node the robot can visit anymore, so it just goes back. Yeah. This basically tries to find the way it can go. It has never visited, and if there isn't, it steps back and then try to find another not unvisited direction and continues that. Okay, so with this in my mind, let me start the implementation. It's saying the time complexity, it would be assuming that there are n cells, it tries to visit all the cells, and maybe the same cell can be visited maybe 3 or 4 times. Firstly, when I visited, then I have still 3 directions. So if I go, to the up direction and maybe come back, and right direction and come back. down direction and come back. But in total, it takes 4 times for each node, so it should be O of n. And for space complexity, I will need back directions, which can be at max. I mean, the whole direction up to n lengths when I visited the zigzag way for the cells. And for the visited set, it should be O of n because it can be up to n cells, visited cells. So in total, space complexity should be O of n. Okay, good. I will start my implementation. Let me assume the start position is 0, 0. And what I will do is I will push into the stack. Wait, I think I don't need stack here. I just need current pointer. And I will take a look at the direction. Wait a minute. I see. Wait, so I need to move. Wait a minute. So I will start from 0, 0 and I will try to visit. Sorry, I still haven't have the clear image of the structure of the code. So let me write some code and I will use it to structure my code. And I will make sure that next row, next column is not visited yet. That's what it means. For now, I will hard code the direction as the string, but probably I will left or right. Okay, so also I will give this direction. And the thing is, I will do the direction 4 times. Wait a minute, so I think I need the recursion for this. Wait a minute. If I use stack, it doesn't work. Yeah, I think using the recursion makes it much easier. So sorry, so back directions visited. Yes, and or I should say I will pass back directions also in the recursion. So in that way I don't need this back directions stack. So in this way I will just keep visited set and visit. And I will start from current row 0, current 0, current direction 0. And back direction is none. So from here in visit method, I will visit every direction. So I will move current direction first, then current direction plus left, then current direction plus right direction. Then I will move back. So yeah, I think this is not needed because back direction is something I don't need. Because back direction is the opposite current direction. But I think I still need it because if I come back to the original position, yeah. So wait a minute, so back direction is I think needed. Yeah, I think. Yeah, back direction can be none. So in that case, I don't have to move backward. Otherwise, I mean, command the robot to move back. in the end of this method. And after that, the recursion goes back to the caller method, which means that the current position is moved by, stepped back by 1. Okay, so let me do that. So when firstly I will try to move forward. So robot.move. I will check if I can move or not. Wait. This actually moves the robot into one position forward. So okay, so firstly I remove the robot.move. Okay, so let me see. Firstly, I will check. What do you mean? So if I move left, what happens? And if I move right, what happens? So sorry. Let me define this. Left direction changes. So with this, if robot is, to the moving to facing to the direction, say upward, then left direction changes the direction to -0. And if it was moving -1, 0, it will move to 1, 0. And the robot is, if originally moving facing to 1, 0, it will face 0, 1. Then if robot was originally moving facing 0, 1, it should come to 0, -1. Yeah. Okay. So with this, first thing I would do is I will check if left change needed. So what I will do first is left direction changes, then yeah, right direction, current direction. Then left moved. So in this way, this left row red column is at the position where it should be. And I will check if this is already visited. Because if this is already visited, I don't have to visit left. I don't have to move left, face left, then move forward. So, I don't even have to move left. So, robot will turn left and try to move. Then, if a move is true, this means that robot has moved forward. So, oh wait, so yeah, so robot moved, so I will visit with left row, left column, then current direction, current row direction, and can go back. So this is a bit tricky because when I move left and if I move forward, which direction? Yeah, the left row direction, left column direction. Yeah, and it can come back to this current node. Yeah, so this is it. Okay. Yeah. Then after this recursion method is called, it comes back to the current position. And after that, I need to robot.turn right. And then now it is moving to the current column direction. Yeah. Okay. And after that, I will check right direction. Okay, and let me just define right direction also. So I just have to swap key value pairs. So from line 101, I will try to face right direction, and if I move right direction, I will be reaching right R, right column. So if already visited, I actually don't have to move even face right. But if it is not visited, it was facing right, so I do it in line 104, and the robot try to move. And if moving is possible. Now the robot has moved forward, so and it's now at right row, right column position. I will do that. And after visiting it, the robot should turn left. So now again, robot is now facing the original direction. So what I should do next is move backward. However, this is needed only when the robot has come from somewhere, not from the. I mean, if the robot is at the start, I shouldn't move backward. I think I can move backward, even if I'm at the. Yeah. Hard. Okay, so let me just remove this. And let me move backward. So backward. So I will try to move down left and turn left again. And now the current row. Wait, I think I don't have to take care of the current row direction anymore. Yeah. I just have to move turn left, and then robot.move. But this way robot has physical position of robot has moved one step back, and then recursion also comes back, and now the position is as the previous one. But after moving that, I have to, reverse the direction of the robot by calling it twice. Yeah. So the robot is facing us the same direction again. Okay, let me check my code again. So I use the recursion, and I make sure that I have the oh, sorry, and I have to also make sure that I append the current row current column to the visited set. Okay. Yes. Okay. So I start from some point, some cell, and firstly, I will I will mark the current cell as visited, and after that, I will try to move left or right, or move forward also. Oh, I forgot to do that. So forward, roll forward. Okay. So firstly, I will try to move forward. So if I move forward, the robot should get forward row, forward column, and if already visited, it doesn't worth moving forward. But it hasn't, I will just move forward. Robot will move forward. And if the robot can move forward, I will continue the recursion. But if the robot cannot move, I don't do anything. Yeah. And just in case, if I come back from this recursive method, the robot is facing the same direction as it was, because in 124 and 25, I make sure that the robot is moving, facing the same direction as, yeah, it did. Okay. Then in line 100, I will try to move left, forward, left, and then move, but I have to make sure that it left direction is still not visited. So in 102, if it's not visited yet, it was trying. The robot turns left and then try to move in 104. If he could move, yeah, I will call the recursive method. Then after that, robot will turn right, which is facing the same direction again. Good. And in line 131, I will try to move. I will check right forward facing is worth doing. So in 113, if right row, right column is not visited, it was trying, so robot turns right and then try to move forward. And if it's possible, it will do the iteration. Recursion. Then after that, in line 118, robot turns left, and now it moves facing the current row direction, current column direction, original one. Then in 120, robot moves backward. I have to make sure that the robot goes back, and now it's moving the same direction. Oh, but here in 123, it is not necessarily true, because if the robot comes back to the original position, start position, it is possible that it can't move backward. So yeah, from the original first function call, recursive function call, it will try to move backward to down, but it is possible that there is a wall below the original position of the robot. In that case, robot move fails and it will be false. So I deleted that. Yeah, session. Okay, I will execute my code. So here, we'll do that. Okay. And here, oh, robot is not passed. So let me share it. Hmm. 30 rooms were not clean. Wait, I think there aren't so many stairs. I think there aren't 30 rooms in total. I'm just wondering. Let me take a look at this example. So current row, current column should start with 0, 0. This is a relative, position. Oh wait, switching. So I see. So one thing I have to take care is wait a minute. I didn't take care of the wall or empty. So 0 is the wall and 1 is the empty. So wait. What are the interfaces? Oh, cream. Sorry, I have to clean it. Let's see. Here, I have to clean the room. Yeah, let me rename visited with cleaned. Yeah. So I think in this way it works. And it's robot.clean. Okay, so for first example, for case 2, it passed. But for case 1, not yet. It seems like 2 is the cleaned room. But there are some rooms which has not been cleaned yet. Wait a minute, so let me quickly clean this up. Okay. Let me read through my code. Hmm. Yeah, this looks good. Turn left, turn left. Move. Okay. One more thing, let me quickly check this. Okay. You got 1, 0. Wait. Negative 1, 0. Sorry, this is incorrect. If negative 1, 0 moves right, upward to right is rightward, so this should be 0, 1. And for 1, 0, sorry, we'll keep this order. So if this is moving upward, it should move rightward. Okay. If this is moving leftward, it should face upward. And if it was move facing rightward, it should look at below. And if it is facing, no, sorry, if this is moving upward with turning right, it should move to rightward. Yes. And so for this was moving down, so it should now move to left direction. Okay, and finally in line 78, if this is now moving right, it should move to up. So it should be negative 1, 0. And if in line 76, if it was moving up, then now it should move right. Sorry, this was down. So here, this is moving left, so it should move up. If this was moving up, it should move right. If this was moving down, it should move left. If it was moving right, it should move up. Okay. Yeah. Just in case, I will quickly check this left direction changes also. 0 minus 1 is moving right, so it should move to up. If this was moving left, no, it was moving up, it should move to left. What? This is correct. And if this was moving up, no, down, it should move right. Okay. And if it was moving right, then it should move up. If this was moving left, it should move down. Okay. Yeah, probably what I should do is left direction or up direction. I should define those as a separate variable and then use it as use it in this hash map. Let me. Down direction should be 0, right direction should be 0, 1. Oh, up direction appeared 3 times. So I think, yeah, something wrong with this direction. Up is near to 1, 0. Left is 0, near to. Down is 1, 0. Left is 0, near to 1. So if originally it was moving the right direction, then if I move left, it should be up, yes. If I'm moving left, and if I move right, it should be down direction. Okay, good. Wait a minute. So wait, if I'm moving left direction, the right direction be up direction. Up direction, right. Right direction to down direction. Then down direction to left direction. Okay, good. So all the problem was within this directions conversion hash map. Okay, I will submit my code. Okay, wrong answer. So this one is empty slot, and so in this example, so it seems like this and this, and their empty slot. And it will start from 0, 0. This robot is not here. So what I should do is, firstly, robot cleans the current room, then robot moves forward and robot moves. Okay. Let me just test this case with keeping the. Oh wait, so what I should do is robot should firstly upward check and leftward check, rightward check, and tries to go back. And it should go back because, yeah, robot.down is not visited yet. Here, it visits the previous cell. Oh wait, robot.move. I think this doesn't assume. I see, I totally understood. So I have to make sure that okay, I see. The problem here is that robot starts from going up, and when it comes to the original position by the down, it assumes that that's the end. However, I also have to visit downward. Yeah. And keep going. Yeah. So what I can do is, in the main method, I will move down. Then with the current direction 0, 1, 0, I will visit again. And it goes to downward. So going downward from the, going kind of backward from the original. I mean, position is not dumb, so I abandoned it. Good, now I will submit my code. Okay, so finally it's accepted. Good. So let me quickly wrap up this question. So this is the hard question about robot room cleaner. And the hardest thing about this question is that the robot is blind. So I can control the robot which direction to go, and if there is wall in front of that or not. But robot, aside from that, I have no information about the given grid. So I use some techniques in this question. The first thing is I use the, relative position from the start cell and stored it in the visited set so that the robot doesn't visit the same places again and again. And I use the recursion. So after moving the robot to the new position, I try to see if I should move left or forward or right. Then if it was visiting, the robot visited. And one thing which I had to take care is that before calling the recursive function or finishing the recursive function, I have to call the robot.move and robot.turn left or something, so that the robot is facing to the, sorry. So before calling the recursive function, I have to move for robot.move so that the robot position is already moved when the recursive function is called. And the operation inside of that recursive called function is started. And also when I come back, return from the recursive function, I have to make sure that the robot position is reverted back to the caller implementation's position, caller's position. And also I have to make sure that the robot direction is also as the original direction. Okay, good. So I will finish my today's coding practice with this. Thank you so much. Bye.